Now, other thing about complex numbers is just how we talk about a thing that has a real part and an imaginary part. Again, this design here is actually created by complex numbers. And when we talk about this, what we're going to do is we're always going to put the real number first, and then we're going to add or subtract the imaginary second part. So for example, we have 3 plus 2i. This right here is a complex number. You have to have both. There is no way that you can combine them. You have 3 grapes plus 2 oranges. Those are never going to work combining. So you have 3 plus 2i. That is your number. That's your entire number. Here's another entire number. We have 1 minus 5i. And I know that you're thinking, oh, hey, well, I could just combine the 1 and the 5. No, because these are connected by multiplication. You can't do that. You can't undo that through addition or subtraction. So it's going to have to stay as 1 minus 5i. It's the same thing as when you do 1 plus root 3. You can't combine those. You just kind of stick with it. So when you see something that's 3 plus 2i or 1 minus 5i or anything like that, it's a complex number. It means that you have a real part and an imaginary part. And this is useful because we have imaginary quadratics. And so remember, when we're trying to solve them, we're just looking for when the graph will cross the x-axis. Well, when a graph never crosses the x-axis, you're going to have imaginary roots. Take, for example, this one here, y is equal to x squared minus 2. This never crosses the x-axis, but it still has roots according to the fundamental theorem of algebra. And so when we solve it with square roots or the quadratic formula, we're going to end up with an imaginary number, and that will be our imaginary root. So now what we're going to do is we're going to go ahead and try and solve this one. This one is going to end up having an unreal answer. And if we go ahead and work on this, I'm just going to choose to solve this one using square roots because I don't have a b term, and so that seems like the easiest option for me. Remember that when we're trying to solve with square roots, we need to set it up so that we have our squared term on one side and our numbers on the other. So we're going to go ahead and subtract 7 from both sides, and we'll have 9a squared is equal to negative 7. Now at this point, a squared is still not by itself, so we have to divide by 9 to get it by itself. Now we have a squared is equal to negative 7 over 9. I'm going to go ahead and take the square root of both sides. Remember that when we take the square root of both sides, we have to remember the upside down on the number side. So we're going to have plus or minus the square root of this junk. And remember that when we take a square root of a fraction, we take the square root of the top and divide it by the square root of the bottom. So now we have the square root of negative 7 divided by the square root of 9. And we're going to have to simplify this now. So that's plus or minus. There's that negative number in there, so we'll pull out an I, and we'll be left with a 7. And the square root of 9 is just 3. So our answer here is that a is equal to plus or minus I root 7 over 3. Or in other words, it does actually eventually cross the x-axis, but it's in this imaginary plane that we can't actually see. Okay, so what I want you to do now is I want you to solve these quadratics using whatever way you want to. If you want to attack them with square roots, then you can do that. If you want to attack them with the quadratic formula, you can do that. If you want to try and factor them, you can also try that, but just as a hint, it's not going to factor, so don't do that one. You can try it, just don't actually go through it. And once you get to the point where you have an imaginary number, go ahead and pull that out, set it up into complex form, and you should end up with these should be nice and easy problems to get you some good imaginary roots. Once you've done that, you're good for the day. Have a great time and keep practicing.